in Singapore, after going through this process of revamping our curriculum, in 1982, for the first time, we implemented what we have today. So all the research done in the early 80s and late 70s accumulated in a textbook, and that was called Primary Mathematics. We're not so creative back then. It's a book for primary mathematics, so the title of the book is Primary Mathematics. And by 1992, it became so evident that this is the right way to go. It was now implemented formally. So in the 80s, it was implemented on the quiet. The teachers were not told that, oh, we are doing problem solving. The teachers were merely given the books and said, go and teach. After 10 years, it was clear that this is the right way to go, and we formalized our problem solving curriculum. So what we have today, problem solving curriculum, was introduced in 1982, formalized 10 years later. You know, in Singapore, we take a long time to do things like that, because in the early years, we didn't know what was happening. So we were struggling. And nobody was giving us answers, except all these books that cannot speak to us or answer our questions. So we were quite cautious, and hence, you see, the 10 years taken to research on the curriculum. And by 1997, this approach became so clear. It's the way to go. It was broadened to include other subjects. In 1997, no less than the then Prime Minister, Goh Chok Tong, announced to the country that we are going to be using this Thinking Schools Learning Nation philosophy, which essentially is the philosophy of the problem-solving curriculum, first introduced in mathematics, but now broadened to include every single school subject. By 2001, the Ministry of Education was confident enough that private publishers can do the job. Previously, they wanted to make sure, so they do not let just any Tom, Dick and Harry wrote the books. They form groups comprising of Ministry of Education officials to work on the book and engage the predecessor of Marshall Cavendish Education to edit the book and print the book. But the authorship, it was the Ministry of Education. But by 2001, they were confident. A lot of people in the system understood this already, and we now have private publishers coming in. And by 2007, we revised the curriculum. We have new sets of textbook, the second edition, and next year, you heard, we have the third edition. And fundamental to the Singapore curriculum is this whole idea that mathematics, and I quote, mathematics is an excellent vehicle for the development and improvement of a person's intellectual competence, unquote. Mathematics is a vehicle. Notice the metaphor the Ministry of Education have carefully selected. It's a vehicle, it's not the destination. Put it bluntly, who cares about finding factors of 36? Not important, really not important. Do you find factors of 36 daily when you go to the supermarket? You don't. Who cares about the mathematics itself? Oh, can the students do mathematics? Of course they can. Nothing difficult of finding factors of 36. More importantly, what do they learn when they are finding the factors of 36? The mathematics is not the goal. The goal is intellectual competence. The goal is intellectual capacity. That is what the future workers in any country needs. Not knowing how to find factors of 36. Not knowing how to factorize a quadratic equation. Who cares about this? Something without a brain, a software, can factorize quadratic expressions quite easily. But we need our future workers to all have strong intellectual capacities. If we have that, we no longer have to worry for them. We no longer have to worry for the future economy of the country. This is very clearly stated in the curriculum document under the chapter called Rationale. Why, in the first place, we teach mathematics, or any subjects for that matter. So this is, as I've shown you, accumulation of years and years and years of work, refinement, research, and what we have today is a curriculum that is problem-solving driven, that basically says that mathematics is a platform. So if you ask me for a short answer, What do you have today in Singapore as far as mathematics curriculum is concerned? Two simple answers. It focuses on problem solving and it perceives mathematics not as a goal, which is a surprise to some of us listening now. But you mean the goal is not to learn the mathematics? Of course not. Who cares about solving 2x minus 1 equals to 0? Really, who cares? Can the students do it? Of course they can. They better can. Because so can something without brains. Softwares can solve very complex equations. And if our students cannot do that, something is wrong with our instruction, not with our students, of course. But what do they learn out of learning how to solve 2x minus 1 equal to 0? That's more important. This is just a slide to tell you we did not start off well. Many of us living in Asia, we know there are two kinds of Asia. There's a homogeneous Asia comprising of the North Asian countries. Korea is very homogeneous. Japan is very homogeneous. China, Hong Kong, Taiwan, they are very homogeneous society. And then there is the Southeast Asian nations where we are. And we are heterogeneous. Traditionally, homogeneous Asia perform well in education and everything else. Traditionally, heterogeneous Asia do badly in education and everything else. That has been a very clear picture right from the beginning. Eric Hanushek, a professor of economics who specializes in education economics, has done quite a lot of work. And what he did was he quantified how different nations perform at international benchmarking studies. And he summarized this, and I will share with you a table comprising of Asian nations. You can read Eric Hanushek's work in greater detail if you are interested in about your own particular region. He works for the World Bank on many projects, and that's what he does. By the 1980s, when Singapore first took part in some international studies, no surprise, we are heterogeneous Asia, and we belong to heterogeneous Asia, and we have the profile of heterogeneous Asia. We were doing not great in education, and we were together with our neighbors, Thailand and the Philippines. But because of changes that happened in the system, by 1990s, and it continued on, Singapore has sort of like defied the profile by moving up to join Japan, Korea, Hong Kong, the homogeneous Asia. In other words, our children's future is not predestined by where they are born, who are their parents. It's determined by education. You heard this morning, education is the instrument to close the gap. You heard also this morning, we are not yet able to do that in Singapore. We are making some progress, but we are doing better in many other places. We are not there yet. But we believe strongly that education is the instrument, and that is why, fortunately, the government has the political will to continue to work on this. So we know we have the right instrument, just that the instrument may not be good enough, and maybe it's good enough, but we are not using it in the best way. So we need to help the users of the instrument, namely our teachers, to use the instrument better, to continue to sustain and make progress in this area. So what do we have today is something that seems to work, but not perfect yet. And whatever that we have done today came from the work from all over the world. In particular, in the US, the NCTM, National Council of Teachers of Mathematics, in the early 80s, in a very important document called An Agenda for Action, says that problem solving, and I quote, must be the focus of school mathematics. It's very clear, the message. What's our agenda for action? What is it that must be the thing we are working on? Problem solving. Around the same time, in the UK, the Cockcroft report says that problem solving is at the heart of mathematics. It's something so critical. We listened to this bunch of research, we checked it ourselves for 10 years, and we knew they were correct. And today, we have a problem-solving curriculum. So my job this morning in a half an hour is to share with you what we have today as far as mathematics curriculum is concerned. We have a problem-solving curriculum. In other words, problem solving is very important. It will appear very clearly in the curriculum document. It will appear very clearly in the textbook. It will appear very clearly in the assessment. So our national tests focus a lot on problem solving. In a primary school leaving examination, about 50% of the points are given for problem solving. In other words, if you cannot do problem solving, you might fail the test. That's how serious we take problem solving to be. And that's an important lesson we learn. If we say it is important, we must work through it. Same message we got from Professor Gopinathan. And that is characteristic of the Singapore Ministry of Education. They said problem solving is important, and they make sure any publisher wanting to publish a textbook must make it important. We make sure the national test focuses on problem solving. Unfortunately, the only thing it cannot make sure of is what happens in the classroom. In other words, we got to make sure the teachers we prepare are good enough that they will do it. There's one place we cannot check. It's impossible, logistically. Curriculum document you can check. Textbooks you can check. National tests, you're in control. What happens behind closed doors in a classroom is out of any Ministry of Education control. But what it has control over is the quality of teachers. It's a challenge, but it's something we can do. If we prepare the teachers well, then we no longer worry about what happened behind closed doors. We can be rest assured that most of the children in the system will get the quality instruction that they so deserve. The details are not important, but this is the curriculum framework for Singapore. When you just glance at it, you can see what is at the center of everything. The message is crystal clear. So the group that came up with this in the early 90s decided to present this in the document because any teacher will not miss what is the main goal. One look at it without reading, you see mathematical problem solving. This is what we have today, despite many revision to the curriculum in 2001, in 2007, and next year, we continue to use this as our guiding framework. So what are the key focus of Singapore mathematics curriculum today? You have heard it all. The first one is problem solving. The second one is emphasis on thinking, because our goal, the destination, is intellectual competence. We merely use mathematics as a platform, as a vehicle. And finally, conceptual understanding. We are not interested in students just being able to compute. It's no big deal. Brainless things can compute. It's called a calculator that comes with my iPhone. I don't even pay for it. It came free. Even if I do not want it, I still do not know how to remove it. It's that valueless. It's given to you, even if you do not want it. It doesn't even have a value, and it can learn how to compute. So clearly, just being able to compute is cannot be the goal anymore, right? So that is why conceptual understanding is so important. Because in learning something conceptually, we are training the minds of the young people. The content itself is not important, but the experience of grappling with abstraction is to prepare the mind for subsequent stages of learning and eventually, of course, the workplace. I show you a few examples from the ancient textbooks of Singapore. You know it's ancient because it's like two color. So these were our textbooks in the 80s. You can see the absence of language. How do they learn times table? No teacher should say, sit down there and memorize. If they do that, I call that malpractice. That's not what the book says. The book says, give them diagram, get them to figure out, if you know 6 times 5, which most people can remember, then can you figure out 6 times 6? And the little girl there says, oh, it's easy, because you just add 30 and 6. If you know 6 times 5 is 30, then 6 times 6 is just another group of 6. Or the picture shows another row of 6. You notice the absence of language. This was 1980s. Many students do not know English language well enough. teachers did not know English well enough. But how do we go about teaching in English? The textbooks were written in a way that allowed this to happen. The use of visual is so obvious in a Singapore textbook since the 80s, and it continues to be obvious today. Because the goal of mathematics instruction, who cares about times table? I know we are obsessed with times table, with multiplication table, but honestly, who cares? A lot of non-living things can remember way more than times table, like my thumb drive. It costs 30 Singapore dollars. It's so small, it's fit into my pocket. This thing can memorize so much information. Our students are not good in memorizing. That's not the way the brain is designed to be. Who cares about memorizing anyway? It's not a valued skill anymore. It costs $30. Is that the value of our future workers? So how we teach mathematics is important. Are we teaching them to be memorizer? Or are we teaching them to be able to use the brain to visualize, to see things, and to make connection? So you can see these are just pages and pages from the old textbook, not even today's textbook, that emphasize on visualization. So when they learn how to add, or in this case subtract, add and subtract, you see the visual, very realistic, like real flowers, and then afterwards the visual become more abstract, just boxes, and afterwards no longer one for one, it's just a whole row like that, and you got to understand that's actually 90 and that's 54, to eventually no more visual. That's what we have in Singapore today. This obsession with making sure, especially for the struggling learners, the path is clear. We cannot leave it to chance. We cannot say, it's okay, we do it any way we like, because the parents will take care of them. Sure, if they are from affluent homes, the parents will take care of them, never mind the system. But what about children from poorer homes, whom parents cannot and cannot afford to provide that education? They come to school relying on the system. Do the system fail them? In Singapore, we have today, we are hoping the answer is not. We are not perfect at that yet, but we are trying. We are trying to make sure a child gets a very clear learning path, never mind what kind of homes they come from. The textbooks always emphasize on the use of concrete material. That's what we have today, and I've spoken about that at length this morning. I will not elaborate on the point. We have a problem-solving curriculum. We have a curriculum that emphasizes on visualization. And how do we get the visualization? We use concrete materials. So the use of concrete materials is very evident in any Singapore textbooks. What do we have today? This is a present-day textbook. You continue to see the use of visual. In this case, to help them in solving word problems. Word problems are always very difficult because it's managing information. Information management, especially in a foreign language, is difficult. So what do? We help them to manage information by giving them a tool, and in this case, the tool also sharpens their ability to visualize. And these are just other examples you see. What else do we have in Singapore mathematics curriculum today other than emphasis on visualization? It's an emphasis on looking for patterns for the purpose of generalizing it. So Singapore mathematics focuses on problem solving. It focuses on the ability to see using the mind, visualization. It focuses on spotting patterns and generalizing patterns. And we use mathematics to do that. So here you notice that we want the students to realize that if they know what is 8 times 4, then they know 8 times 8 is double. If they know what is 9 times 4, then they know what is 9 times 8. And some kids will not say, oh, so if I know 7 times 4, then I know 7 times 8. So they spotted a pattern. If you know times 4, you know times 8. And some kids say, oh, teacher, that means I know times 16 also. So they have spotted a pattern and they generalized it. So the emphasis on looking for patterns is another thing in the present day Singapore curriculum. And it didn't just begin like that. It was based on what we did in the early days, and we always try to answer the question, what do we teach and how do we teach it? This morning I shared with you the answer to how we teach it. We use research. Now I'm sharing with you what do we teach. We teach problem solving, we teach generalization, we teach visualization. This is a school in Singapore. It's a very common sight. Why would they do such a thing? It's for students to realize, oh, if I know 3 times 3, I know 3 times 6. It's double. If I know 4 times 3, I know 4 times 6 is double. So we want students to see connections, not just in the classroom, but everywhere around them, in the environment. Present-day textbook will have explicit requests to engage in things like looking for pattern. So this is an example where they are asked, in the end, the instruction was, do you see a pattern? So no teacher will mistake, because if the teacher uses this page, they will end up whatever the activity is with the question, do you see a pattern? Do you notice a pattern? So the emphasis on looking for patterns. These are just other examples that I put in your own time. You can look at them. Is to make the point that, so what do we teach today? So let me just summarize. We teach problem solving. We teach, what's the second thing we teach? Visualization. What else do we teach? Generalization, looking for patterns. And we teach number sense. We want them to develop this human ability. So, do you know how to add 94 plus 9? Oh, I know, because they're both close to 100. That's a human ability. Very few machines can do this, but most humans can do this. Oh, they're both close to 100, so the answer is close to 200. Oh, but it's too much. I take away 6 because it's 94. I take away 3 because it's 97. That's a human ability. We are not interested in calculation, but we're interested in mental strategies to develop number sense. Okay? So essentially that's what I wanted to share with you, and there are just other examples you will see in our textbooks that emphasizes on problem solving. What else? Visualization, generalization, and number sense. And these are all human competencies. So essentially what Singapore textbook does is to sharpen students' human competencies related to mathematics, and the last few examples I gave you are not even related to mathematics. Like journal writing is to emphasize on communication. It borders on the use of language already. In some countries this is taught under English language or whatever language that you teach. But in Singapore, we also integrate it into mathematics instruction. So our students are expected to do things like that in mathematics. Problem solving, visualization, generalization, number sense, which are mathematical in nature, and then communication, and metacognition, which is ability to spot mistakes. Ability to say, this is wrong, this is not so right, let me improve on it. And this is not mathematical, it's a general intellectual capacity. So this morning, my job in a short time is to share with you what is the Singapore mathematics curriculum. Main message is mathematics is a vehicle. The goal is intellectual competence. Some people call this higher order thinking, like problem solving, visualization, generalization. I forgot what it is. Number sense, and communication, as well as metacognition. So you will see examples like open-ended tasks, where students have to pull together quite a lot of different ideas to respond to a task. And that's where I want to end. This morning I did mention to you in the 2013 mathematics curriculum, we begin to pay attention to mathematical modeling, which essentially is starting with a real-world situation, get the students to formulate a mathematics problem based on the real-world situation, and afterwards solve the mathematics problem, get a solution, and then take the solution and feed it back to the real-life situation. So that is what we have today, and the last slide I'm showing you is what's happening in the near future, meaning starting next year, greater emphasis on mathematical modeling, getting the kids together to put together all the things they have learned. Main message this morning is mathematics curriculum in Singapore is focusing more on the human aspects of learning as opposed to memorizing, doing procedures, and doing difficult calculation. Memorizing can be taken care of by my thumb drive. No need a human to do it. Following procedures, we have simple machines and complex robots to do that for us. Calculation, the free calculator that comes with your cell phone. With that, thank you very much.